Hello guys, welcome to Ramta Solutions. Welcome to your lesson on grade 12 functions and inverses. Today we are looking at the quadratic functions and their inverses. So you remember quadratic functions come in two forms, the equations rather come in two forms. The first form is f of x equals a x squared plus bx plus c, right? So this is the first form of your quadratic equation. Now, let's look at what these parameters are representing, especially the a and the c. So this a represents the dilation of the curve, right? Represents the dilation of the curve. If a is greater than -1 but less than 1, greater or equal to but less or equal to +1. Okay, greater equal to -1 but less or equal to -1. It'll be a narrow curve. But if a is greater than -1 or less than, so if a is greater than +1 or less than -1, the curve will be wider. Okay, the curve will be wider. So maybe let me represent this. When a, I'm going to use a red color, maybe it can work. When a is greater or equal to -1 but less or equal to 1, it'll be a narrow curve. Okay, it'll be a narrow curve. Okay, and then when a is less than or equal to less or equal to -1, or when a not less or equal to but less than -1, or when a is greater than +1, it'll be wider, right? It'll be wider. Okay, now let's then look at another point. Is this when point 2, this a represents the, I'm going to call it concavity. So this is where we're talking maxima and minima. When a is positive, your graph is smiling. This we say it's concave up, otherwise it's minima. And then when a is negative, your graph is frowning. This is concave down. This is what we call maxima, right? This is what we call maxima. So when a is positive, your graph is smiling. When a is negative, your graph is frowning. So this, we call it a minimum because the lowest y value is that of the turning point. And this, it's called a maximum because the highest y value is that of the turning point. This b will basically affect your your y value of the turning point. It affects almost everything. Okay, it affects almost everything. So we're not going to look much into it. Okay, we're not going to look much into it. It affects your x-intercept. It affects how your function moves to the left or to the right. It also affects how your function moves up and down. It is playing a role in those. So we're not going to talk much about it. But this c, we're going to talk about it. This c is what we call the y-intercept. Okay, it is a constant, as you can see. It is a y-intercept. This is where the graph cuts the y-axis. Okay, this is where the graph cuts the y-axis. So meaning the y-axis or the y-intercept will have the coordinates 0 and c. Okay, and the y-intercept will have coordinates 0 and c. I don't know what's happening. Let me switch it off for now. So the y-intercept will have 0 and c. So these are all to know about these parameters. Now, let's get to know some important information of these. Let's begin with the axis of symmetry. With the axis of symmetry, this is the line that cuts the graph into two equal halves. Okay, now that line is when x is equal to -b/2a. for the parabola or the quadratic function given in this form to find your axis of symmetry. This is, you say x is equal to negative b over 2a. And by the way, this is also x value of the turning point. Okay, it is also x value of the turning point. X value of the turning point. All right, it is also x value of the turning point. Okay, perfect. Now, let's then look at the turning point itself. Let's look at the turning point now. The turning point, when you are given the quadratic in the form y equals ax squared plus bx plus c, it will be the x value is that of the axis of symmetry, which is negative b over 2a. And substitute that axis of symmetry into your original equation, then you will get the y value of the turning point. Okay, you will get the y value of the turning point. Remember, turning point is where your curve changes from being an increasing function to a decreasing function and vice versa. Okay, so this is what I mean. Here it's decreasing, and then to the turning point it changes to be increasing. Decreasing changes to increasing. Do you see this? Oh yeah. All right. So this is what we call a critical point of, it's basically critical value of your, or critical point of your curve. Okay, it's called a critical point of your curve. Right. Now let's look at the domain. Now for the domain for the parabola or the quadratic curve, it always allows all x values. Okay, it always allows all x values. All x values you can think of will give you a y value. Okay, all x values you can think of will give you a y value. Now let's look at the range. The range, and by the way, when we talk of the domain, we're talking of the values of x, right? And those values, we also refer to movement from the left to the right. If also you do not like this form, you can say x is an element of negative integer in parentheses to positive infinity, not integer. Negative infinity to positive infinity. You can also use this form, but I prefer this one. Eh? Okay, now with the range, it is the set of output values. Right? It is the set of output values. Here we are referring to which y values are our functions possible at. So we need to look at first when a is positive and when a is negative. Remember, when a is positive, your function is smiling. When a is negative, your function is frowning. So what is this? When a is positive, your function is, let's look at it. When a is positive, this is your function, it's smiling. So the lowest y value is that of the turning point. All right, so the lowest. So this means we must say y is greater. But not only that, the point, the function also exists at that lowest point, hence equal to. So equal to what? F of negative b over 2a. You guys recall I said negative b over 2a is corresponding y value of the axis of symmetry. All right, if you substitute your axis of symmetry into your original equation, you will get the y value of the turning point. All right, and here, as you can see, y exists at this point, but it must also be below this point. Hence, you will say less than. So y is less or equal to y value of the turning point. Okay, y value of the turning point. Okay, so this is it. This is the domain and range of your quadratic functions. Now, let's look at your quadratic functions when they have a different form. When they have a different form, the second form, rather, not shouldn't be saying different. It is when it is a f of x equals a open bracket x plus p close square plus q. Okay, so this A still means the same thing as in the first form. So we're going to focus on the P. This P, ooh, this P represents what we call horizontal translation, or I like saying horizontal shift. Okay, horizontal translation. Okay, so this is horizontal shift. What does it mean? It is involved with movement left or right. Okay, it is involved with movement left or right. Okay, so when this P is positive, your function will be shifting to the left, and then when this P is negative, your function will be moving to the right. If you can remember this, if ultimately you find that you have x minus p, sorry, if you can find that ultimately you have in open bracket x minus whatever value, it means your function has moved to the right. If you have open bracket x plus whatever value close square, it means it is moving to the left. Okay, now this is all we can say. Now, it is also, but we'll not talk about it. Let's leave it for here. Now, this, maybe I can. It's also, let me say this. It's also x value of the turning point. It is also x value of the turning point. It is also x value of the turning point. Okay, it is also x value of the turning point. When I say x value of the turning point, let me just leave it here. I should also mention it is the axis of symmetry, represents the axis of symmetry. All right, represents axis of symmetry. All right, represents axis of symmetry. Okay, represents axis of symmetry. Remember, what did we say about axis of symmetry? It is a line that cuts the graph into two equal halves. Now let's look at Q. What does it represent? First and first, it represents the vertical shift. It represents vertical shift. Vertical shift is involved with what? Movement up and down of your graph, right? So when this Q is positive, your graph will be shifting up. And then when this Q is negative, your graph will be shifting down. Okay. Secondly, it represents the Y value. It is the Y value of the turning point. Okay, it is the Y value of the turning point. Okay, it is the Y value of the turning point. Okay, it is the Y value of the turning point. So this is your your quadratic functions and their two forms. All right, we are not done, by the way. Now let's look at the axis of symmetry. The axis of symmetry, remember, it is a line that cuts the graph into two equal halves. When you are given your equation in the second form, it will be x equals negative p. Okay, it will be x equals negative p. Now, the turning point, the turning point, the turning point will be the axis of symmetry, which is negative p, and the q value. Remember, I said q is y value of the turning point, as it is. Okay, the domain, it's still the same, it doesn't matter. So the domain, it's still the same, it doesn't matter. So the domain, it's still x is an element of real numbers, right? X is an element of real numbers. Whichever x value you can think of will always return a corresponding y value. Now let's talk of the range. And if you recall, we said domain is a set of input values. The range is a set of output values. Here, we need to focus on the curves when A is positive and when A is negative. Remember, when A is positive, it's a smiling one. When A is negative, it's a frowning one. Right? So with this one, as you can see, it's a minimum. So we will say this must be when y is equal to that q value, but also greater than that. So it'll be y equals to, y is greater or equal to q. And here, as you can see, it touches the point. So it is when y is equal to the q value. But not only that, also below the q value, it's valid. So when y is less or equal to q, this is the range of your parabola. Otherwise, your quadratic functions. That's what you call them as well, right? Perfect. Now, let's try an example. By the way, this video will be a bit long because we will be covering many aspects. Example, sketch the graph of f of x equals x squared minus 4. Okay, minus 4. The solution, as you can see, this is in the form y equals ax squared plus bx plus c, right? So we then say, let's begin with the y-intercept. The y-intercept, it's clear. This is a constant. Let me just write it in full. Y-intercept, it'll be 0 and negative 4, right? Remember I said it is 0 and c, right? As you can see, c is negative 4. Now let's get the x-intercept. Let's get the x-intercept. The x-intercept will be f of x must be equal to 0. Remember, f of x is similar to saying y. So y is equal to 0. So this is x squared minus 4 equals 0. Difference of two squares. X minus 2, x plus 2 equals 0. So here, x equals 2 or x equals negative 2. Therefore, the x-intercepts are negative 2 and 0 and what? And positive 2 and 0. Okay? Perfect. Moving on, the axis of symmetry here will be 0, but I will show you. The axis of symmetry, remember we said it has the form x equals negative b over 2a. What is the value of b? It's 0. What is the value of a? It's 1. Let me remind you, just to highlight, a here is 1, b is 0, c is negative 4. Right? So, axis of symmetry is 0. Right? Axis of symmetry is 0. Now, turning point, first thing first, I will need f of 0, right? Because what is f of 0? F of the axis of symmetry. Remember, this is the y value of the turning point. We say the axis of symmetry was 0. So this will be, where does x you put 0? So it means it is negative 4, right? Therefore, our turning point is 0 and negative 4. Guys, I know when it's in this form, it's easy for you to tell that it is 0 and negative 4. Of course, this is what you did in grade 10, but we are making use of the formula so you get to see these things, okay? All right. The domain will be x is an element of real numbers. It's always like that. The range, remember what I said. As you can see here, a is positive, meaning we expect a graph that's smiling. So the range will be y is greater or equal to this guy here. And what was this guy here? So this is a point that you know, right? This is a point that you know. So we are expecting y will be greater or equal to y value of the turning point was negative 4. So our range will be y is greater or equal to negative 4. Now let's begin to plot. Now as we plot, we will have, let me plot, maybe come to the This is the new page. hmm Okay, I have to use a grid so it can somehow give me a grid would do. Let me see. Okay, let me come to the center here. Okay. It was -4, so it means I can just say 2 1. Okay, 2 1. 1 2 3 4. That's fine. 1 2 3 0 1 2 3. Yeah, let me try 4. Yeah, 4 5. Okay. Yeah. Negative negative. 2. Okay, 3 1 kill. Okay, this is X and this is Y. Okay, so we said X intercepts are -2 and +2, and Y intercept was -4. So our graph, I can remove the grid now. Our graph is something like this. Right, our graph is something like this. Okay, our graph is something like this. Right, remember guys, I'm not drawing it to scale. Okay, it is not drawn to scale. This is your quadratic graph. Okay, this is your quadratic graph. Okay, good. So this is how it looks like. As you can see, it is the lowest y value is -4, and it allows all other values. Can you see that? It allows all other y values. All other y values above -4 are valid. Right? So we were right with our domain, I mean our range. Okay, so this is it. So let me just write the points. This is -2 and 0, and this is 2 and 0, and this is negative. Oh, sorry, it's 0 and -4. This is 0 and -4. Okay, perfect. Now, proceeding, we are content. Now, let's then head to determining inverse. Determining inverse. So when we determine inverse, remember, inverse f to the -1 of x is a reflection is a reflection of uh, is a reflection of f of x on the line y equals x. What does it mean? It means what was y now becomes x. What was x becomes y. So I'm gonna go back to the graph that we had. Right? I'm gonna find the inverse function of the inverse graph, not function, inverse graph of this function. Okay, so now check this out. This is point -2 and 0. When it changes, it's going to be 0 and -2. I'm going to show you. It's going to be 0 and -2. As you can see, 0 and -2. This is 2 and 0. When it changes, it's going to be point what? It's going to be point 0 and 2. This is 0 and -4. When it changes, it's going to be -4 and 0. -4 and 0. Okay, then this will be the inverse. This will be the inverse of f. Okay, it will be the inverse of f. As you can see, this inverse, when you look at it, it is not a function. Why? Because one x value has two y values. Therefore, it is not a function. So this is you now, given a graph, this is you drawing the inverse of your function. But this inverse is not a function. Okay, this inverse is not a function. Okay, now determining the inverse, remember the inverse is a reflection of f of x on the line y equals x. Now we're going to try an example. Example, determine the equation of the inverse. Determine the equation of the inverse of f of x equals x squared minus 4 and sketch this inverse. And sketch and draw the graph of this inverse, okay? And draw the graph of this inverse, okay? And draw the graph of this inverse, okay? Let's go. So let's determine the equation. So what do we do when we determine the equation? We had our solution. So our solution, we had, remember, f of x is similar to saying y. It was equal to x squared minus 4, isn't it? X squared minus 4. I like writing the statement reflecting on y equals x. So what does it mean? Where there's x you put y, where there's y you put x. So x equals y squared minus 4, right? So what is this? X plus 4 equals y squared. Now you know when you kill the square root, you multiply by the reciprocal of the inverse rather of your thingy of your square, which will be half. So it'll be, let's see, 2 to the half. So this will be plus minus, right? You multiplying by half, power half. So power half is similar to a square root. It'll be x plus 4 equals y. So as you can see, this is basically plus minus x plus 4, right? Plus minus x plus 4. Now let's imagine this. So you see, now we have found the equation of our inverse. Now let's imagine this. When x is negative 4, check this out, negative 4, it will be negative 4 plus 4 is 0. Let's go check. When x is negative 4, we have 0, isn't it? We have 0. Do you see it? Now let's check when x is 0. When x is 0, 0 plus 4, we have two values, positive. Square root of 4, by the way, is 2. So therefore, we have y equals plus minus 2, meaning one y value is positive 2 and the other y value is negative 2. This is it. We are done. We sketched this graph, isn't it? So we sketched this graph, right? Now, I had said this inverse is not a function. Remember, for you to determine if your graph is a function or your equation is a function, one x value must correspond to exactly one y value. But if one x value has more than one y value, then that is not a graph. Okay, perfect. Havash. Now, let's see. Determine the equation of the inverse of f of x. So we're going to say we fine. So we are fine. We are fine. We said this was not n. We said this was not, the inverse was not a function. So now the part that we're going to look at is restricting the domain, okay, restricting the domain of f of x, especially the quadratic, okay, of f of x. So the inverse is a function. So the inverse is a function. Okay. So let's say we are given f of x equals x squared minus 4. Okay. Let's say we are given f of x equals x squared minus 4. We know what this looks like. As you can see, this looks like this, right? Now, to restrict it, to restrict, right, to restrict the domain, we have to look at the axis of symmetry. To restrict the domain, look at the axis of symmetry. Look at the axis of symmetry. Okay, so we're going to take 1/2 of the axis of symmetry. So for example, we're going to take when x, let's say when x is less or equal to 0. All right, when x is less or equal to 0, I'm going to show you this graph. So now let's say this f of x is equal to x squared minus 4, but the restriction is that x is less or equal to 0. What is the inverse? What is the inverse? So the inverse will be, if you recall, we said the inverse is this. We said the inverse is plus minus x squared plus 4. Was it x squared? No, x. The inverse was x plus 4. Let me remind you guys, this is what we said here, right? The inverse is x plus 4, isn't it? So let me show you on the curve. You see, this is the inverse, right? This is the inverse, right? As you can see that this is the inverse. Sorry, this is the this is the function with the restricted domain. Do you see that? We said x is less or equal to 0. That means you are moving to the left, right? So this is the one that we are looking at. Okay, so let me just draw it in order for you to see it. It will be something like this, so I shouldn't be it's -2, -4. I will then need -2. I'll also need -4 here. So if you recall, it was something like this. All right, it was something like this. This is f. Should I change the colors? Let me change the colors, otherwise it's gonna make the space untidy. Let me change the colors. Yeah, let me change the colors. So this is -2, -4. This is -2, -4. Right? So if you recall, that one, the original was like this. Right? The original was like this. And then now this is the original. Now the inverse has to be like, guys, may I use this green color? I'm not sure. As you can see, it'll be like this. All right? It'll be like this. Okay? It'll be like this. Okay? This is how you restrict the domain. Now check this out. Now when you look at the inverse, exactly now, one x value has exactly one y value corresponding to it. So this is now what? It is a function. All right? It is a function. Now, to restrict this domain, we have restricted this domain. Therefore, when we have restricted this domain, remember what was y becomes x, what was x becomes y. So now we will then say, because we have said this, you don't have to be plus minus, buddy. You will be minus. Okay? You will be minus. Okay? You will be minus. All right? As simple as that. All right? As simple as that. You can do the same. You can do the same, or you can do the same, or you can do the same for this, right? You can do the same or for when you say x is greater than 0. Okay, when you say x is greater than 0, you can do the same. So you see, now that you have said when x is less or equal to 0, check, the domain will be minus the square root, right? And you are good to go. Now again, you have seen what was the domain becomes the range, whereas the range becomes the domain. But let's now summarize. Let's now summarize. Now the summary, I have to copy that graph that we had. Okay, I have to copy it. I will copy it. Copy to current. Now paste here. I'm just gonna make it shorter, smaller rather. Okay. So in our summary, I want us to look at this. I want us to look at, we're gonna say x-intercept, y-intercept. We're gonna look at the domain. We're gonna look at the range. Okay. We're gonna look at the turning point. Okay, allow me to call this TP. Original. Sorry. Let me do this. Separate now. Original. Inverse. Now let's check it out. What was the x-intercept for the original? It was 0 and 2. 0 and 2. And not 0 and 2, man. 2 and 0. It was 2 and 0, or negative 2 and 0, and positive 2 and 0. So what is the x-intercept for thingy? For the inverse, it was negative 4 and 0. Negative 4 and 0. Okay. What was the y-intercept for the original? It was 0 and negative 4. 0 and negative 4. And then what was the y-intercept for the inverse? It was 0, 0 and negative 2, right? And 0 and positive 2. What was the domain for the original? X is an element of real numbers. What was the domain for the inverse? X is greater or equal to negative 4. Can you see that? The range for the original, y is greater or equal to negative 4. The range for the inverse, y allows all y values. Right? What was the turning point? Here it was, for the original, 0 and negative 4. For the inverse, it was minus 4 and 0. Okay, guys? Now, I want us to look at this. And I'm going to copy again this section. I'm going to copy again this section in the next, so that I can use it in the next page. Okay? Yeah. However, I'm getting rid of you here. Okay? I want you guys to look at this. I'm going to use it now here. Okay, I'm going to use it here now. Okay, maybe let me, yeah, better. Okay, what do you see, guys? Again, so generally, x-intercept will become y-intercept. Remember, you just swap the values, guys. You just swap the values. Okay? And then turning point, no, not, let's look at the y-intercept. Y-intercept will become the x-intercept. Do you see this? Look, what was the x-intercept of your original? Became the y-intercept of your inverse, with the values swapped. Okay, with the values swapped. Whereas the y-intercept of your original became the x-intercept of your inverse, with the values swapped. What was the domain? Became the range. Where there's y you put x, where there's x you put y. So what is the domain? Became the range, right? And then what was the range? What was the range? Look at this. The range now becomes the domain. You're only changing the y's and the x's. Okay, these are the things that you will be using. Okay, these are the things that you will be using. And to be honest with you, this is it. This is all that you need for your quadratic functions. Okay, this is all that you need for your quadratic functions. Remember, when you dealing with inverses, what was x becomes y, what was y becomes x. If it was an x-intercept, it will become the y-intercept, but swap the values. Okay, as we have seen, here, the y value, the x value is -2, the y is 0. Obviously, it must swap. It'll be 0 and -2. That's a y-intercept. It was 2 and 0. It will swap. It becomes 0 and 2. So this is a y-intercept. You get it? Just like that. Then we are done. All right. So with that being said, ours ends here. And remember to get in touch with us by visiting our website www.ramtasolutions.co.za, or because you are watching this video on YouTube, in the description of this video you will find the links to the different social media platforms. And by the way, you can also now follow us on WhatsApp. We have created a WhatsApp which we call Ramta Solutions Exam Ace. Okay, Exam Ace. So there you will get updates on how to pass different topics and updates on the latest videos that we upload on YouTube and different social media platforms. Okay, so with that being said, you know we care for you, and all the best with your studies. So bye bye.